My name is Shalyn Combs. This is my fourth video, and I am doing it on muscle metabolism, the ATP synthesis, and energy usage. Now, all muscles depend on ATP, which is an energy molecule, and there are two main pathways of ATP synthesis: anaerobic and aerobic. Anaerobic fermentation enables a cell to produce ATP without oxygen. However, it does produce very little ATP. And aerobic respiration produces a lot of ATP, but it needs a continued supply of oxygen to do so. Now, glycolysis, start at the top in the beginning, is a process of producing the ATP beginning with glucose. And glucose is broken down by enzymes into pyruvic acid. And then the pyruvic acid has the two outcomes of anaerobic fermentation and aerobic respiration. There are three ATP sources for muscle contraction. We have the immediate, short-term, and long-term. And so we'll start with the immediate. It has the aerobic respiration. And then it also has the phosphagen system. Under the phosphagen system is used after the aerobic respiration is gone. So it uses ADP instead of producing more ATP. Now, under the phosphagen system is the myokinase and the creatine kinase. Now, the top one, the myokinase, it's an enzyme. It removes a phosphate group from a molecule of ADP, and this frees a phosphate and results in converting ADP into adenosine monophosphate, which is AMP. This is removed. Phosphate is now added to another molecule, ADP, to produce a now usable molecule, ATP. And then with the creatine kinase, the other enzyme is this creatine kinase, and it removes a phosphate from a phosphate storage molecule and donates it to ADP to make ATP. And so I hope that makes sense. I'm not the most artistic of people, so okay, so that is for your immediate source of energy. Then you have the short-term energy, which is glycogen, lactic acid system, which is an aerobic or anaerobic fermentation. It is the anaerobic fermentation. It produces two ATPs. So maybe we should put this back down. It produces two ATPs, and for each glucose consumed. And it can produce enough ATP for 30 to 40 seconds of maximum activity. So an example they used in a book is running around the bases at a baseball game, or if you ever had field day in grade school, and those short races they would have you run, those would also be a good example of the short term. And then you have the long term, which is the aerobic respiration. And if oxygen is present, pyruvic acid from glucose can be converted into a lot of ATP. And to sustain this aerobic respiration, the body needs sufficient supplies of oxygen and glucose. And so if you're going to run like a race, not a race, but more long term, like a marathon, you would need the aerobic respiration. You'd need that long term energy. Now, it kind of goes in cycles. And again, I'm sorry for lack of artistic talent, but you can kind of see the process of the duration of the exercise. You have the here the aerobic respiration using oxygen from myoglobin, and then you have the phosphagen system, and remember it's used after the aerobic respiration is gone. It uses ADP instead of making more ATP. And then you go on to the next phase of glycogen lactate system, which is the anaerobic fermentation, and it does produce the ATP. And then the last is the EPOC, which is excessive post-exercise oxygen consumption. And that's where their aerobic respiration is supported by cardiopulmonary function. And it just goes in a cycle. Once your muscles are rested, then it can start this process over again. Anyway, that is my presentation on the muscle metabolism. Sorry.